You may have remembered a little while back I posted a video where I showed how I made the server cabinet and 3D printer storage that you can see slightly behind me. You may also notice that the 3D printer is no longer on top of that cabinet and there is another piece of furniture behind me. That piece is my new 3D printer enclosure, and in this video I'm going to be going over why and how I built it. Let's first start with the why. Specifically, why make a full enclosure and not just plop it in an end table and call it a day? Well, that brings up the first reason why I had to move it in the first place, and that is prints failing due to temperature fluctuations. When printing, it's a good idea to keep the bed and the print at a pretty consistent temperature. If you don't, you can have prints shrinking or losing adhesion, and one thing that might happen is that the prints detach from the print bed while being printed. Now, obviously this is bad, and for me at least, the issue can be traced back to these ceiling air vents I have in my office. The way the registers of these vents are made, they actually direct the air directly towards my 3D printer, and in the summer when they're blowing cold air, it often causes the prints to pop off the bed. They also have a habit of blowing a lot of dust into the printer over time, which is also not the most ideal. The second reason for moving into an enclosure is to be able to print more filament types. PLA is pretty forgiving and flexible in its print environment, but other filaments aren't, and some even give off bad smelling fumes. So by pulling it all into an enclosure, I can better contain all that and have much more controlled environment. The third reason is so that I can also muffle the sound just a bit. 3D printers are not really known for being the most silent, they definitely aren't loud, but having one just a few feet away from me can be a bit annoying. So by putting it into an enclosure and not the open air, I can make it just that little bit more quiet. Lastly, the printer used to be sitting on top of a server cabinet, and I am now finally getting around to building an actual server and NAS to put into it along with my Raspberry Pis. Which, if you're already subscribed to my channel, you should consider doing so that you don't miss my video on going over how I built my server and my plans for it. Now, mechanical hard drives don't like a lot of vibrations, and while this is printing, it definitely vibrated the cabinet a bit. Basically, I just don't want to increase my chances of a drive failure. With my reasons and explanation for making this enclosure out of the way, let's talk about how I actually went about making it. Now, I owe a huge thank you to this Instructables post that I got my inspiration and basis for doing this project from, so be sure to check that out in the description below if you want to do something similar to this yourself. The basic concept of this is to take 2 or more of these IKEA lac end tables and stack them on top of each other, creating both the printer enclosure as well as some storage space. I bought 3 of them so that the printer would be higher off the ground for easier access, but not too high off the ground that it would look kind of weird in the background. I first assembled all 3 tables, which required a lot of twisting parts together, but once assembled and stacked, you could really see the plan start to come together. These tables are not very stable, just casually stacked, so I used some dowels and wood glue to more securely connect them. I simply drilled matching holes into the top of one of the tables and the bottom of the legs of another table and stuck the dowel between. It was at this point that I learned that the legs of the table are actually hollow after about half an inch of wood, so I didn't need to worry too much about getting the hole depths correct. I also didn't put the holes into the center of the legs just so that I could avoid any issues with the existing screws holding the legs to the table, though it may not have been totally necessary. I will also note that the hollow legs make it very easy to lose dowels inside of them when connecting the 2 tables together. It gets pushed inside due to not lining things up correctly. I may have lost a few myself. Now with all 3 tables stacked, it was time to move on to the enclosure side panels. This is where I had to start to deviate from the original Instructables post. I did end up sticking with using acrylic for the side panels to fully enclose everything, so I opted to make all 4 sides removable instead of just the front, and hard mounting the other 3. Really, it's just a personal preference to make things more accessible, and since I was already making one removable, why not just make them all removable? Another thing to note is that I am also in the US, and the Instructables creator was very much not in the US, as everything was referred to in metric units. This is not a problem except for the fact that I can't really buy 400 by 450 millimeter acrylic panels because while there were nice round numbers in metric, that's not really the case for Imperial, so I ended up having to buy larger panels and then cut them down to size. I had never cut acrylic before, though I found out it was not all that difficult. That being said, my tolerances were not the best, and I was left with gaps on either sides of the panels, but this didn't need to be sealed anyways, so it was fine. This was also another reason why I contributed to making all 4 panels removable. With all the panels cut out, I needed to attach them to the tables in a way that would allow me to remove them. I opted to use the same method that the Instructables used, but just apply it to all 4 panes. I first epoxied 4 magnets to each panel while forgetting to check each magnet's polarity. If you do this yourself, don't make that mistake or else you'll be left with panels that cannot be swapped and have to always go back into the same exact spots. At any rate, I also printed out my own handles for the acrylic because the Instructables didn't link the one they used, and also because I liked the one that I printed out a little bit more. I continued to epoxy the handles to the panes and the magnets to the metal brackets that would be used to hold the acrylic in place. Again, because I messed up the polarity, I had to be careful and match up the polarity of the magnets I epoxied to the brackets. This also carried over to mounting the brackets, as I had to make sure the correct polarity was put at the correct spots. In case I ever made it clear, don't be like me and mix up the magnet polarities. Anyways, once I screwed all of the brackets to the tables, I could test fit and make sure all the acrylic panels both fit into the spaces and would hold up and not just fall off. The magnets were a bit weaker than I would have wanted, and these slight rotational mismatches here and there also hurt their strength, but overall I didn't fear anything would fall off with operational vibrations. I also made sure that the panes were recessed into the spaces and were also leaning into the top slightly, that way gravity would also be helping. And with that, the enclosure is well enclosed. But we do have one issue. My 3D printer has its spools mounted onto the top, extending its overall height to where it would no longer fit inside the enclosure. I now need to remedy this by moving the spools outside the enclosure and drilling a hole in the top of the table so the filament can pass inside to the printer. This also means I need some more custom printed parts to, one, make somewhat of a guard around the hole just to make it look a bit cleaner, and also to have some rollers for the filament to sit on, with the help of some cheap bearings off Amazon, allow the filament spools to sit and rotate freely as the filament is fed into the printer. There were no instructions or notes on the instructions page about this step, even though you can clearly see the creator did need to do this as well. If you have a smaller printer or a side mounted holder, you may need to adapt this as needed. I also took this opportunity to print out a case for my old Pi 2 to be able to mount it to the metal structure of the printer and run Octoprint off it to give me some more control of the printer. The only thing left now is to install some nice LED lights inside the enclosure to both allow me to see the build plate, but also because it looks cool. Originally I was going to go full RGB lights, but that would require either a microcontroller or a remote controlled system, and honestly that just made it all more complicated. I just decided to buy some basic short strips of 12 volt LED lights and stick them to the underside of the table. All 4 strips would be wired up in parallel with a common power, also getting routed through a nice rocker switch that I mounted into the leg of one of the enclosure tables. The fact the legs were hollow actually helped me a lot and made recessing the switch easy while passing through the wires. I finished by securing all the wires to the ceiling with some small cable hooks that were simply nailed into place, and crimped the remaining wires together, and voila, my new 3D printer enclosure is complete. Wish I could say it ends there and that this thing lives happily ever after, but unfortunately it's not been all rosy. Don't get me wrong, this totally works and I'll be using it, but given this is a DIY log of my build for this, I feel like I should sort of do a post-mortem of sorts and talk about what isn't quite working right. To start, my 3D printer fits, but by the thinnest of margins, and it actually technically doesn't fit in one respect. I have the Prusa i3 MK3, and I can tell you straight up, if your printer is any bigger than mine, it will not fit this enclosure. There is essentially zero room left, and the back panel will actually get pushed out if the build plate extends all the way back. And if the print head goes with its maximum Y, the filament would certainly snap due to the tight bend angles it would have to be put into. That being said, I currently just run without the back panel for now, and might actually switch to a hard mounted one for the back anyways, which would be on the outside of the table leg, giving it that extra inch it needs. And as far as the print head goes, there really isn't any reason for it to go that high, and if it does, well then I guess I lose a few inches of my filament. Oh well. Also, did I mention me messing up the magnet polarization, because that was a really annoying mistake. Some slightly stronger magnets would also be nice, but not totally needed. In terms of things that went well, actually the lighting and wiring. The switch is beautifully recessed in the table leg, and the lights work beautifully with no cables showing. Maybe it's just because electrical and wiring are one of my weak points, but I'm really proud of how it turned out here. In the end, this is definitely not perfect and has lots of room for improvement, but I'm still happy with how it turned out. And it was a great learning experience to help me get better at making this stuff. I'm glad I've made it, and hopefully with some small tweaks I can make it even better, but for now I'm just glad it's no longer on top of my servers. Anyways, hopefully you guys have enjoyed this video, and hopefully it's either inspired you or helped you make something similar. Consider subscribing if you've enjoyed this video, and stay tuned for my future video going over how I made my new NAS and server that I will now have in my server cabinet. At any rate, thank you all for watching. I'll catch you guys next time. Peace out.